Hello, my name is Cormac McGuinness. I'm representing as president of the European Synchrotron and Free-Electron Laser User Organization and coming to you from Trinity College Dublin in Ireland. And I'm going to introduce you to the synchrotron and FEL light source landscape in Europe. So very welcome to this NEPHEWS virtual training. And so I should talk about the light source landscape in terms of both its research infrastructures and their scientists and their users. So the light source research infrastructures, if I borrow a definition from the lightsources.org website, are accelerator-based facilities that generate the most intense, tunable, and controllable beams and pulses of X-ray, ultraviolet, and infrared light that we can use for all sorts of science today. They allow us to access and study processes and matter over the widest variety of energy scales, length scales, and time scales, making possible both basic and applied research, fields ranging from physics to biology and technology, not otherwise possible with conventional equipment, and represent state-of-the-art facilities that are accessible to European users and to users from beyond Europe as well. So the large-scale research infrastructures are the cornerstone of the European research area and help to promote innovation, growth, as well as attracting the best minds to Europe from around the world to access these facilities, inclusive of the synchrotron and free electron laser facilities, which are represented in terms of the light source research infrastructure. The landscape of these research infrastructures is represented by the consortium known as the League of European Accelerator-Based Photon Sources, or LEAPS, which is the consortium of Europe's synchrotron and free electron laser sources spread across 16 institutions with 19 different facilities. The light source users in Europe are represented by the European Synchrotron and Free Electron Laser User Organization, ESUO, which represents and lobbies for European users and their interests, with delegates from 32 member nations and their respective national user organizations. So if you take a look at the map of Europe with illustrating the LEAPS facilities, LEAPS is the largest network of research infrastructures in Europe, comprised of synchrotron radiation sources and free electron laser facilities. So if you're an entirely novice user, I can illustrate this very briefly in terms of what a synchrotron is. And so a synchrotron is a source of X-rays, ultraviolet, and infrared light, which is produced through a linear accelerator, where electrons are accelerated and then boosted in energy through a booster synchrotron. And then they travel through a lattice of magnetic and electrical RF cavities, which keeps them accelerating at very, very high energies. And it's these high energy electrons which then emit as a bunch of electrons passes through a magnetic structure. They emit pulses of light which can travel down through beam lines. So we can have multiple beam lines at a given synchrotron, and then this can deliver X-rays or indeed infrared light to users at these facilities. Free electron laser system is a little different in that it is a linear accelerator where the electrons are accelerated through either relatively short or extremely long linear accelerators, and then through magnetic devices known as undulators, where then the X-rays are generated. And so there can be multiple different beam lines at such a free electron laser facility, where the electrons are dumped rather than being continuously reused. But then the electron source and the light source in a free electron laser facility can provide even shorter pulses of X-ray light in the region of attoseconds, as is the case in the European XFEL facility. So the LEAPS network of synchrotrons and FELs spans 10 countries, involving 16 institutions, which are shown here, and 19 facilities, as some of these institutions operate both a synchrotron radiation source and a free electron laser facility. And so all told, across all of these different sources and facilities, there are more than 300 operating experimental beamlines and end stations with tailored state-of-the-art equipment to do specific research tasks related to almost any subject within material science, chemistry, biology, geology, food science, semiconductors, physics, and so on. The user base of these facilities, we sees about 35,000 users per year from all across the EU and beyond the EU, delivering approximately 1 million hours of beam time each year, generating as much as 7,000 or more publications in recent years, and where protein crystallography and macromolecular crystallography is involved, generating as many as 55,000 protein data bank entries. So this spans materials for energy, life science, pharmacy, food, information technology, the environment, as well as all sorts of materials. And so we can emphasize this a little bit more in terms of the range of materials which are illustrated, from either batteries or viruses, such as the COVID virus, earth science and environmental science applications, as well as new materials such as graphene or other two-dimensional materials, as well as semiconductor technologies, and even all sorts of science related to food. Now, the LEAPS initiative, the LEAPS consortium, have very recently published examples and scientific highlights of the impacts that these light source facilities have had or are having in terms of the world-class research for our daily lives, where all sorts of different societal challenges are being tackled at these accelerator-based photon sources. So this was published as recently as December 6, 2024, and so this can be found on the LEAPS website. But how do these facilities and the light source landscape in general and their users, what are their roles within the European research area? Well, LEAPS infrastructures and their users have become an integral part of the research and innovation landscape of Europe and indeed of the world. If we look at this, in effect, organogram detailing how the LEAPS facilities interact with their users in terms of the academic users who are based at either universities or research institutions, or users from industry. Industry is involved both as a user, but also as a technical partner or supplier related to the equipment which is used at these facilities. And so we can see the use of these facilities by the academic users, by the industrial users, and by the investment and connection with industry in supplying the LEAPS facilities with the equipment that they need. LEAPS does not operate solely by itself. There are all sorts of different joint projects with other European research infrastructures in the European research area, as well as partnerships with companies, with other consortia, and with other different research infrastructures in joint projects. Now, the funding for the LEAPS facilities obviously has to come from somewhere, and this comes through the governing bodies of the facilities themselves. Generally, the majority of the funding is coming from national research ministries, but a significant part also arises from the European Commission. And the reason why all of this is occurring is because the science at these LEAPS facilities, these light sources, are truly transformative for the science that is achievable by European researchers. And so this has an impact on society in terms of the knowledge transfer, also the spin-offs that arise from the research that takes place at LEAPS facilities, and then circulating within society, thousands of skilled jobs arising from those users who are trained in these facilities, as well as the scientific beamline staff and those at the facilities themselves. So if we look at the reference period over the 2021-2027 period, the operating budget of these facilities totaled as much as 800 million euro. And over this time period, this also represented an additional capital investments of nearly 1.6 billion, while there's another 1.5 billion planned in terms of upgrading these facilities over the period and into the next period, some of which has already been allocated. So let's have a further look at these facilities. Okay. So in terms of access to LEAP's facilities in Europe for users, this can either be occurring through facilities which are open access or international member facilities. So open access nationally funded facilities are open to all users and all of their proposals, where beam time is awarded and allocated based solely on the scientific excellence and feasibility related to the proposal and of the teams. Typically, for most facilities, there are 2 calls per annum, but there are other access modes which exist. Separately, there are international member facilities, in particular the European Synchrotron Radiation Facility in Grenoble and the European X-ray free electron laser facility in Hamburg, or EU-FEL, ESRF. These are member organizations funded by member states who are partners or shareholders, and beam time is allocated to these research teams from the subscribing member states. But there can be exceptions based on excellence, compelling, or urgent science proposals. Typically, there are 2 calls per annum, but again, other specific kinds of access modes exist. So if we take a list of the open access synchrotron radiation facilities, in alphabetically, we have ALBA, the DESI institution and the Petra 3 synchrotron, the Diamond light source in the UK, the Electra light source, at HZB in Berlin, the BESSI 2 light source, at INFN in Rome, at ISA, the Astrid 2 light source, at Max IV laboratory in Sweden, at the Paul Scherrer Institute, the Swiss light source, Soleil synchrotron in Paris, and then the Solaris Radiation Research Center in Poland, and the Sesame facility in Jordan. And the open access free electron laser facilities at DESI, there is the Flash free electron laser. At Electra, there is the Fermi free electron laser. In the Netherlands, there is the Felix facility. And at HZDR in Dresden, there is the ELBA free electron laser. And at Paul Scherrer Institute, there is the Swiss FEL. And then in Turkey, there is the Turkish Accelerator Radiation Laboratory of Ankara. And as I said, there's the international membership synchrotron radiation facility, the European Synchrotron Radiation Facility in Grenoble, and the international membership facility for X-ray free electron lasers is the European X-ray free electron laser at Hamburg. In addition to that, not an open access facility is the metrology light source in Berlin, run by the PTB. So most open access LEAPs RI presented here participate in the NEPHEWS project and that project's transnational access or TNA scheme. Others who are not participating in NEPHEWS are possibly currently undergoing upgrades or have specific funding or access restrictions or the absence of user programs or already offer alternative funding streams in order for external users to access them. So I'm going to take a quick tour around Europe just to illustrate these facilities and where they are in Europe. So here, this is the ALBA facility outside of Barcelona, and you can see the picture here of the ALBA facility, and this is a QR code which will take you to their website. So going around these in order, here we have in alphabetic sequence, we have the DESI facility outside Hamburg, where there's both the Petra 3 and the Flash free electron laser, the Petra 3 synchrotron and the Flash free electron laser. There's the Diamond light source synchrotron in the United Kingdom outside Oxford, near Didcot. There's the Electra facility in Trieste, which runs both the Electra synchrotron and the Fermi free electron laser. In Grenoble, there's the European Synchrotron Radiation Facility, which is seen here in the photo, the largest facility in Europe at present. In Hamburg, near to DESI, is the European X-ray free electron laser facility, or the EU-FEL. Continuing our tour, then we can go to, in the Netherlands, the Felix, the free electron laser facility for the infrared experiments at Nijmegen, the Netherlands. In Berlin, at the Helmholtz Zentrum Berlin, we have the BESSY2 synchrotron. In Dresden, at the Helmholtz Zentrum Dresden-Rossendorf, we have the ELBE free-electron laser facility. We also have the synchrotron at the INFN in Rome. At Aarhus, we have the ISA and Astrid 2 synchrotron. At Lund in Sweden, we have the MAX 4 facility, and which actually has two synchrotrons within the same laboratory. And then continuing our tour to the Paul Scherrer Institute, we have the Swiss light source, and then the Swiss FEL, or Swiss free-electron laser, at Villingen, Switzerland. In Berlin, we have the Physikalische Bureau, or the metrology light source in Berlin, and which does not have a user access program. And at Solaris, in Krakow in Poland, we have the Solaris synchrotron radiation facility. And coming near to the end of our tour, we have the Soleil facility in Paris, France. And then within LEAPS, we have the Sesame synchrotron, but this is not strictly in the European research area, but this is an associate partner of LEAPS in Jordan. And then participating also within NEPHEWS is the Tarla free-electron laser at the Turkish Accelerator Radiation Laboratory of Ankara. So how do we navigate all of the available beamlines, the end stations, the instruments, and the techniques? Well, we need to have an idea of what it is that we want to do. But once we have that idea of what kind of science we want to do, we can use the Way4Light website, okay? The Way4Light website allows us to browse the synchrotron and free electron facilities and look through the catalog of beamlines and end stations, which are searchable by facility, by technique, by discipline, information on sample types, as well as photon energies across all of the synchrotrons and FELs of Europe, but also including a number of the intense laser facilities. So you can go to way4light.eu, and whenever you pick on a particular beamline, you can compare beamlines from different facilities, but you can then, these will link to the facility beamline web pages, which will give you more specific technical details, beamline context, as well as lists of publications. So if you go to the Way4Light website, you can filter for, let's say, X-ray absorption spectroscopy, and then you can pick synchrotrons only, and then you can page through the particular techniques that you want to look at, and then you can scroll down through the pages which lists all of the different beamlines which are available. So how do we put this into a worldwide context in terms of the European light source landscape, in terms of the worldwide context? Well, I'm going to rely on, in this presentation, some recent work available since May of 2024 from the Lund Institute of Advanced Neutron and Electron Science, or LINX, which was published on their website by Martin Stankowski and Farhad Basara. So they address the question concerning the size and output of the global light source and neutron source research communities. So they analyzed the results from the 30 different light source facilities, more than 30 light source facilities globally, both synchrotrons and X-ray lasers and FEL facilities, as well as neutron facilities. If we confine our discussion in this case now just to the synchrotron facilities, data from 1996 to 2023 has already shown a six-fold increase in annual publication output from the light sources in this time. And if we look at the decade from 2012 to 2021 that they reported on in their work, they showed that there was nearly 110,000 light source publications in that decade, with 53% of these having participants or co-authors of these publications based in Europe. So again, we're using some of the materials from their presentation that's available online at this website, at the LINX website. So if we look at the global participation by world, region, and country, here we can see the facilities in Europe, which are denoting both the synchrotrons and, in some cases, the synchrotrons and free electron lasers, such as at DESY and the Paul Scherrer Institute and Valletta, which offer both. And in terms of the publications, we can also see the locations of other synchrotrons, such as the Sesame synchrotron in the Middle East, those in the US, Canada, and South America, Australia, and in the Asia and Pacific region. If, as Martin Stankowski and co-worker has done, they were counting participations, the number of publications that a world region or country appears on in the author affiliations for the paper, then we see 53% of the papers published from light sources have author affiliations from Europe. And so obviously some publications have authors from both Europe or the North America or Middle East or Africa or Asia Pacific. So the sum, these are overlapping sets, so the sum doesn't add up to 100%. So putting that again into a worldwide context, we can look at that in terms of participations within Europe. And so here we see the participations in Europe. It's not surprisingly dominated by those countries which have the greatest users, and these countries are also those countries which have the national facilities themselves, whether this is Germany with multiple facilities, in this case, 5 represented here, and other in France where there are 2, the United Kingdom where there's 1, Italy, Switzerland, Spain, and Sweden. So these reflect the countries with both facilities and large user populations, as well as those countries that are directly participating in the international member facility. But however, we do see that there's a very significant proportion of usage from countries outside of these 10 countries that are where these facilities are located. And this is due within Europe to framework programs integrating activities where what so-called transnational access has benefited users all across Europe in this period. Which brings me to the landscape for users. Okay, so the European Synchrotron and Free-Electron Laser User Organization, or ESUO, represents the users, the photon science users in the European research area since 2010, when we were founded. Today, ESUO represents the 35,000 users of these facilities, and we comprise users or user delegates, national delegates, from 32 different European member states, as well as EU candidates and associated countries and former EU countries represented within our organization, nominated from their national user and also facility user organizations. ESUO is a fully registered non-profit international organization based, registered in Belgium, and supports the establishment of new national user organizations. If I say a few more words about us, ESUO's vision is important. Our ESUO's vision is to support a thriving European synchrotron and FEL user community with equal opportunities of access and participation for all scientists, based solely on the scientific merit of their ideas. Within that, we have a clear mandate from all of our delegates to promote the continued use of transnational access to access these facilities provided by the European Light Sources and the European Commission. We are lobbying continually to support the elimination of geographic or financial barriers in user participation with a simple and access model as practicable. So in terms of what ESUO's missions are, we're representing the users of the SR and FEL facilities. We want to enable strategies for equal transnational access by European scientists, no matter where they are in Europe. We collaborate with other user organizations of other analytic facilities, which I'll describe in a moment. And we are co-developing actions at these facilities, strengthening cooperation with national users organizations, as well as fostering contacts and widening in European neighbor countries and supporting facilities in their creation of equal access opportunities for scientists. So our manifesto, published in 2014, is as relevant today as it was then, and this is called Towards Even Brighter European Photon Science. And so you can download this at our website at esuo.eu. ESUO works toward this with partners such as in NEPHEWS. In terms of access conditions across Europe, there is a slightly unequal playing field depending upon where you are in Europe. And so here we're highlighting those member countries within ESUO in terms of the survey of our members' access conditions. And it's only in countries such as highlighted here, the United Kingdom, France, Spain, and Italy, are there national programs which provide funding for national researchers to access their national facilities. In almost no other country is there a specific funding program to allow access to either national facilities or indeed to international facilities outside of their borders, with the sole exception of Denmark, where there is the DANSCAT, which allows funding to access both the international facilities, whether it's the EU FEL, the ESRF, or indeed any of the open access national facilities. So the demand for funds to pay for travel and subsistence to access light source research infrastructures can be paid for through the European Commission transnational access. And this demand can certainly be met from all of the users across Europe. And so curiosity-driven transnational access remains important, complementary to challenge-driven access. So if we look at the ESRF, the membership, differing membership levels is described in this map here. The EU FEL is the membership map is illustrated in this membership map here. In terms of transnational access programs, NEPHEWS provides TNA for curiosity-driven science. Challenge-driven access across different thematic access programs is available through other European Horizon Europe projects. CEREC ERIC also provides access to a limited range of RI. So why was NEPHEWS? Access is important. It has been very important to users and user communities. And so together with LEAPS and the network of neutron sources, ESUO and the European Neutron Scattering Association network, Scattering Association Users Organization, NEPHEWS has come about, which you're benefiting now in terms of the virtual training. So NEPHEWS provided funded access via TNA to 8 synchrotrons and 5 FELs for excellent curiosity-driven science, regardless of origin. And so you should check our website at NEPHEWS to learn more about this. This will be running until the end of 2026. Other thematic access programs are Remade at ARI, which is a project focused on supporting science with tailored services for to conduct circular materials research and develop the circular economy in materials involving multiple analytical facilities. Rihanna is a similar thematic project providing transnational access, but now specifically in the areas of nanoscience and technology, but again involving much more than just light sources, 69 other analytical or other research infrastructures, Rihanna ending in 31st of August 2027. And the Nanoscience Boundaries and Fine Analysis, or European Pilot, NFFA, also working tools for research at the nanoscale. That continues until early 2026. So I'd like to thank you for your attention. Very happy to answer any questions, as I was answering questions in the live online virtual training. But if you're watching this in the future, I'll be very happy to try to answer questions regarding users and the light source landscape if you contact me at this email address here. There are other topics and talks available within the NEPHEWS virtual training. So lastly, as something to go home with, you could go to visit some videos of both the largest and the smallest of these light source facilities, such as the ESRF in Grenoble, where you could go to these two YouTube videos, which will introduce you to the largest facility in Europe, operating to the highest energy. But you can also then visit, instead of visiting the ESRF, you can visit the example videos to look at the Astrid 2 facility in Aarhus, which illustrates on a much smaller scale the electron bunches generating pulses of synchrotron light at these facilities. So I'll leave you at this point And as I said, you're very welcome to watch these videos. And thank you very much for your attention.